To the campus of North Idaho College and today's broadcast of the North Idaho College Public Forum. The crew is comprised of North Idaho College television students. Your moderator is North Idaho College political scientist Tony Stewart.
Once in a lifetime, we have the opportunity to view something called Halley's comet about every 76 years. We thought it very appropriate since that time had arrived, and we were fortunate enough to observe that very important development that we would talk about that on our program. And we're so fortunate to have on our program today a guest that's been provided by the Convocations Committee at North Idaho College, Dr. Susan Wyckoff, who is an expert in this field. Our guest holds a baccalaureate degree from Mount Holyoke College in Vermont. She also holds a PhD in astrophysics from Case Western Reserve University in Cleveland, Ohio. She's had experience in many fields and many areas, including a tenure at the University of Michigan. She also was abroad for 6 years, and part of that time was at Tel Aviv University. She's now a member of the faculty at Arizona State University. Dr. Wyckoff, it's a pleasure to have you on our program.
Thank you, Tony, very much.
Also, I'd like to welcome to the panel to question our guest today. Our panel, first of all, we have State Senator Mary Lou Reed. We also have Coeur d'Alene Attorney Janelle Burke, and we have from the faculty at North Idaho College in the Division of Physical Sciences, Kurt Nelson. I shall invite Senator Reed to commence the questioning.
Thank you, Tony. Dr. Wyckoff, I'd like to ask you the simplest of all simple questions. Just what is a comet?
Well, that's an excellent question. In fact, a comet is very simply a cosmic snowball. It is a sample of primordial material left over from the formation of the solar system 4.5 billion years ago. It's a marvelous opportunity for astronomers to examine just how the solar system was 4.5 billion years ago.
What do you mean by snowball? Is it made of ice?
Indeed it is. Water ice, the common kind of ice we're all familiar with. It is also composed of a little bit perhaps of methane ice, ammonia ice, other mixtures, but basically it's water ice with a little dirt mixed in with it. So we call it a dirty snowball.
And this dirty snowball is moving. And why?
That's right. It's moving because it is under the influence of the sun's gravity. And because of the sun's gravity, which is a pull of attraction, the little snowball is moving in toward the sun, and Halley's comet itself is getting closer and closer to the sun each day.
I see. Thank you.
Janelle Burke.
Can you give us a little bit of history about Halley's comet? Would you please tell us why it's called Halley's comet, and then something about when it was first sighted and some of the history about this particular comet?
Well, in fact, that's one of the most fascinating things about Halley's comet. Let me first say that the interesting thing about Halley's comet and why it's so important is that it is the brightest comet that has a predictable orbit. As we can predict when it will appear. Most comets appear out of nowhere, almost randomly. But the history is intriguing, and the reason that it's called Halley's comet is related to the fact that Edmund Halley, an astronomer in the 17th century, became intrigued by comets and intrigued by what they were. He noticed their motions in the sky, and Kepler, the previous century, had stated that comets move in straight lines, and Halley didn't believe it. So he went to his friend Isaac Newton, and Isaac Newton said, no, I have a new theory of gravity. Why don't you apply it to the orbits of comets that we know? Halley sat down, and for 23 years, he made calculations using the new theory of gravity of Newton and discovered that comets indeed move in ellipses or in parabolas, different from straight lines. And in fact, what he discovered was that one comet seemed to reappear every 75 or 76 years. He predicted that that comet would reappear in another 75 years, and indeed, in 1759, his prediction came true, and ever since then, the comet has been called, of course, Halley's comet.
Can you tell us if Halley's comet was around before the time that Halley was doing his experiments?
That's right. It was around, of course, before, and people went back to the record books and found that somebody somewhere on Earth had noticed a comet appeared in the sky every 76 years. There were drawings scratched on caves, there were annals that the Chinese had recorded, and now we can trace the history of Halley's comet back to the year 240 BC.
What kind of effect has Halley's comet had when it appeared either in earlier historic times before people knew what it was, when they just saw a bright light in the sky and they thought maybe perhaps it was some kind of supernatural force. What kinds of stories can you tell us about some of the history of early sightings?
It's interesting because, of course, Halley's Comet sightings cover the whole history almost of mankind here on Earth, so that we have the superstitions and the lore, as you've noticed, before people realized that it was an object in the solar system. In fact, it was not until the 16th century that people realized that comets were not something supernatural and not something in the Earth's atmosphere. So there's a long, long history of Halley's Comet appearing in the sky and producing evil, being an evil omen, causing pestilence and disease and war. All these terrible things were attributed to Halley's Comet and to other comets. But of course we know that's all wrong and not fair to do to comets.
I'd like to get one question here, and then we'll go on to Kurt on the panel. When the comet comes through, as you indicate, every 76 years, and then it disappears and we don't have it again, am I correct in my research that it's been described that this and other comets are in what is called a deep freeze storage area in the outer fringes of the solar system? Can you explain what is meant by that?
That's right. The snowball is ice, and it's traveling around the sun because of the sun's gravity. The sun is a source of heat. It heats the Earth to room temperature because of the distance of the Earth from the sun. And Pluto, which is the most distant planet in the solar system, is way out in the deep freeze at almost absolute zero, not quite, a few degrees warmer. But of course, as one goes farther away from the sun, it gets colder and colder and colder. So comets have very oblong, very elliptical orbits that take them, in the case of Halley's Comet, from the distance of Venus from the sun all the way out to the distance of Neptune from the sun. So this poor little snowball, as it comes in toward the sun, undergoes a great change in temperature. It reaches a point in its orbit where it heats up, starts evaporating, in fact, it gets so hot. Then as it moves out from the sun, moves farther away from the sun, it cools off and it goes out into the deep freeze of space.
And if it didn't do that, then it would just disappear, it would melt. Is that the case?
If it lingered very long near the sun, it would melt and evaporate and away to nothing.
Yes. Kurt Nelson.
You imagine this dirty little snowball, or small. What are the approximate sizes of Halley's or other comets comparable to that?
That's a good point here. I'm saying a little snowball, but I'm meaning a dirty snowball that's miles in diameter. It's rather large when you really contemplate thinking about something that large. But even though it's several miles in diameter, each time that a comet goes around the sun, it loses some of its mass because it's evaporating. Because it's losing some of its mass, a comet won't last forever. In fact, we can calculate for Halley's Comet that each time it goes around the sun, this time included, about 1 meter depth of the surface will be evaporated away. So each time the comet returns, it shrinks to a smaller size, and Halley's Comet will last only 1,000 more orbits, or 76,000 years more.
Mary Lou Reed.
Well, where are you going to be, Susan, when the Halley's comes around? Are you going to participate in this International Halley Watch?
Very much so. We have been. In fact, for the last couple of years, we're involved in the International Halley Watch, which is an effort, and a first-time effort, for astronomers throughout the world to coordinate their efforts to make observations of the comet, with the idea being that we will optimize our scientific study of the comet.
And what do you expect to learn? What are some of the studies that are going on? There are different areas, aren't there, that you're parceling out to each other?
That's right. We're one of 7 centers, and our particular center is intent on finding out what kinds of ices make up that little snowball. We want to know the chemical composition of the snowball. And
you do this with some different kinds of machinery. How are you going to analyze?
How to do it? We go to a telescope, a large telescope, preferably here on the Earth somewhere, or we go to space and use telescopes in space. But the idea is to observe the light, to take the light, in fact, and put it through an optical device that spreads the light out into its component colors, into a spectrum. And once we've done that for an astronomical object, it turns out that chemical elements display signatures, fingerprints, that say that they're there and tell us how much of each chemical element is present. So once we see the signature, we see how strong it is, we know how much of that chemical element is in the comet.
And you're one of 7 centers with your task. What else are we expecting that we will learn from this particular flyby of the Halley's Comet?
Okay, the other centers then are involved in studying the radio waves that it's emitting. One is interested in studying the heat that it's putting out. One is interested in examining in detail the structure near the nucleus, how the gases come off the nucleus as they evaporate from the sun's heat. Another discipline will study the tail of the comet. The most intriguing thing about comets is the tail and how they form.
And what it is.
What influences them.
And none of this, of course, was possible in 1910, so this is why you're saying it's a mammoth new opportunity.
That's correct. Never before have we coordinated our observations, number one, and number two, never before have we had such sophisticated equipment to observe comets with before. And in fact, this includes even sending spacecraft to fly through the tail of the comet.
Do you want to talk about that, the spacecraft?
The spacecraft, that's, I think, is the most fascinating thing about this appearance of Halley's Comet and makes it so different from other appearances. 5 spacecraft are on their way to visit the comet. They have all been launched successfully. Everything seems to be working. This traffic jam will arrive in March of 1986 and fly through the tail of the comet. Each of the spacecraft will gather some of the material that is evaporating from the comet, analyze what substances there are, the dust from the comet, the gases from the comet, then by telemetry send that information back to Earth, where we will analyze it and have a new view of a comet we've never had before.
You did say they were unmanned.
They are unmanned, yes.
Janelle Burke.
You're going to be doing all this study of comets. What good are comets? What are they useful for? Or are they useful for anything? And what will you be learning from your studies that will be of help to mankind?
Okay, well, there are always spin-offs. Whenever we go into space and venture out into the frontiers of knowledge, of course, there are always gains. And spin-offs technologically, such as miniaturizing computers, that was a spin-off from the space age, and I expect that in an indirect way will benefit in that sense. But of course, there's no substitute for advancing our knowledge and understanding how the solar system formed, which is what we can do with comets, and only with comets. They contain clues that nothing else in the solar system really contains, and that is they contain clues to the formation of the solar system because they are pristine material. You pick up a rock on Earth, you pick up a rock on Mars or Venus, and it's been weathered and changed in 4.5 billion years, but not a comet. A comet is the pristine stuff, so we can sit and examine it and know what it was like 4.5 billion years ago. This gives us information about how our solar system formed, how it evolved, and maybe even how life originated on our planet, which is awfully important to all of us.
I would like to get into an area that the viewers, I'm sure, have been intrigued by your comments. The average citizen who is viewing this or any other program, and they are excited about their opportunity to see Halley's Comet. How can those persons go about that don't have the equipment that you do and the advantages? What are the dates in which they can see it best, and how could they see it?
Okay, that's a good question, and they may get a better view than we. When we observe the comet, by the way, we're sitting in front of a computer console and typing away and hardly get a chance to think or to see what the comet is doing. The best view of a comet will be had by anybody who wants to make an effort to see it with merely a pair of binoculars or with a naked eye. One doesn't need an expensive telescope. One needs one thing that's important, and that is a dark sky. So I would advise anybody who's interested in seeing Halley's Comet to go to a dark location. That means don't be in a city, don't try to look when the moon is bright in the sky, but go to a dark site to view the comet. The best times, and take binoculars. I think it will help to take binoculars. The binoculars have a wide field of view so that one can see the long tail of the comet best. Then I would suggest for the 2 best times to see the comet to go out in the evening between 7 and 9 p.m., the 1st through the 10th of January, and look toward the southwest shortly after sunset. And there one will have the opportunity to to see one of the spectacles that we don't enjoy very often in the sky. One will see an object that is the head of the comet, maybe as bright as a bright planet, Jupiter, and extending from that head will be a tail, a very faint tail. It might take some time to get your eyes dark adapted to see that tail, but one wants to wait and look patiently, and you'll notice that it's very different from anything else when you see this very faint tail extending from the head and up away from the horizon, because the tails of comets always point away from the sun. The sun will have just set. You're looking in the evening then in January. In March, one will perhaps get a view, at least of the tail, sticking up above the horizon just before dawn. Just before dawn, you can see the tail very low on the southeastern horizon at 5 a.m. It will be more difficult to see than in January from this area because of the northern latitude of Idaho. If you really are an avid Halley fan, one might want to go to a state in the south, in southwestern United States, or to Mexico or to Hawaii to get a better view, and even the southern hemisphere will be best in March and April of 1986.
Thank you very much. Kurt Nelson.
How many comets are projected that there are out in space, and what is there at the origin of all of these? Do they hang around together, or do you think they come from some general place? Are comets characteristic of our own galaxy, or could there be others around?
Interesting question. There probably are trillions of dirty snowballs lingering on the outskirts of the solar system.
Mm-hmm.
Those are the best estimates. Only a half dozen or so are seen each year to come in near the solar system. The trillions of comets are left over from the formation of the solar system. We think that the sun and all of the planets condensed from a big interstellar gas and dust cloud, and left over from that gravitational contraction process was some debris. And the debris condensed into snowballs way out on the periphery of the solar system beyond Pluto, where it's very, very cold. They condensed into snowballs a few miles in diameter and would normally sit out there, these trillions of snowballs, unless a passing star happened to perturb them, which is what we think happens. A star passes by and gravitationally perturbs them. They fall in toward the sun and become comets. Become comets when they start evaporating and flare up and form a tail.
Mary Lou Reed.
Will you talk a little bit about what you called Halley hype or Halley mania? You've been surprised, evidently, at how much interest there has been and how many places you're asked to talk and how excited people are. What are some of the commercial things that are happening, and what are some of the surprises you're running into?
Yes,
as a scientist?
It has been fascinating. Our interest was in studying the comet and trying to learn about the early history of our solar system. And we got into the Halley Watch, where we can organize and coordinate observers to do the science better. But all of a sudden now, this year, people have been knocking on our door and ringing the telephone off the hook, inquiring about where they can view the comet, what they can do. And it's fascinating to me how interested the public is. And I suspect that the origin of this interest is related to the fact that this comet only appears once in a lifetime, once every 76 years. And many of us remember parents or grandparents telling us about their view of the comet in 1910, the last time it was here. And we've waited a long time to see it and to relive what our relatives have relived. So I think part of it is that it only appears once in a lifetime, and the other part of it is that of all the objects that astronomers study, I think comets are the most unusual appearing objects in the sky.
And they're very dramatic.
Yes, yes.
Well, have you been approached by any commercial ventures, people who really are trying to take advantage of this once-in-a-lifetime opportunity?
Yes, we have T-shirts and buttons and, oh, you name it.
Everything. Balloons.
Balloons, the whole bit is being dealt with, at least in the Arizona area and all throughout the country. Yeah.
And do you have any objection to that? Do you think that it's the right thing to make this kind of a party?
I think it's fine to make it a party, and I think it's wonderful to have the public interested in knowing about what's going on in the sky and trying to understand what makes comets work and all of the wonderful questions we've been getting, because it's so very important.
In the midst of all the buttons and the balloons, we're still all certainly learning a tremendous amount about things that we haven't thought about before.
That's right, and it's important that everybody know these things, I feel, and it's fun to have a party while we're doing it.
Janelle Burke.
Would you please explain the differences between some of the different kinds of bodies in space, and particularly, is there any danger that the comet will slip out of its orbit and collide with Earth, such as a meteor, for example, meteorites that come to Earth? Is there any danger with the comet, and how is it different from some of the other bodies in space, a planet, for example?
Okay, differences between, among different kinds of objects. Well, as we know, a comet is simply a dirty snowball, and 2 or 3 miles in diameter. That's small by astronomical standards. There are planets in the solar system. These are made of rocky substances, some of them, and Jupiter and Saturn are mostly gaseous material. In fact, Jupiter may not even have a solid surface in the middle, so it might be more like a star. The Sun, on the other hand, and all stars, the Sun is just a typical star, are big blobs of gas, just holding themselves together by gravity and producing their own energy. Planets shine by reflected light from the Sun. Comets, when they're very far from the Sun, shine by reflected light from that dirty little snowball surface. But when they get in closer to the Sun, that is within Mars' orbit or so, they begin to evaporate and form a big steam cloud, in fact, around the little snowball, and that steam cloud actually begins to glow from the light of the Sun. The sunlight makes a comet glow. The sunlight also, by the way, has pressure. It has light pressure, and this light pressure blows dust out of the atmosphere to form the tail. And that tail shines by reflected light. And as the comet continues around the Sun, I want to make clear, too, that that tail, therefore, then points always away from the Sun. So when you see the comet, I hope you'll all bear in mind that that tail is always pointing away from the Sun. Think where the direction of the Sun is. And it's because it's the light pressure that's making that tail.
Is there any danger that the comet can slip out of orbit and collide with us?
The danger, there is no imminent danger that the comet will ever collide with our Earth, especially Halley's comet. The chances of this happening are 1 chance in a trillion in the next many, many years. Very small a chance that this will happen. It certainly won't happen without us knowing it. Thanks to Isaac Newton, we understand the law of gravity very well. We know where all of the planets are, so that we know exactly and can predict exactly where that comet will be from now through for millions of years. So there's no danger that Halley's comet will collide with us. Comets appear out of the blue in the sky all the time. Not all of them are periodic like Halley's comet. And there is a chance that a comet could collide with the Earth, a comet that just appears out of the sky, out of nowhere. The probability of this happening, again, is extremely minuscule, that one would actually be on collision course with the Earth. But it can happen, and in fact, we think that comets were much more prevalent early in the solar system, that is 4 billion years ago, and that collisions of comets with the Earth happened rather frequently in the early part of the solar system. And it may, in fact, be that comets early in the early part of the solar system affected the chemical composition of the Earth's atmosphere. That is, the comets rained in on the atmosphere, changed its chemical composition, and may have had some influence on the origin of life as a result.
Dr. Wyckoff, I was doing some calculations here, and you indicated it comes every 76 years, and if one was born immediately afterwards and only lived to be 73 or 74, one would not see it in their lifetime. Is it correct that this is the 29th recorded appearance of this comet? And my notes also indicate that in 1456 that Christopher Columbus and Leonardo da Vinci saw it. Is that correct? And did they make any comments about it?
It's certainly correct that the comet will make its, I think it's 29th appearance, something like that, in recorded history. I can't vouch for Leonardo da Vinci having witnessed it, as I wasn't around then, and I don't remember a written report, to be honest with you, but he could well have seen it. And I do know that Mark Twain was born in 1835 when the comet was in the sky, and died in 1910 when it was in the sky.
We might just take a moment to, there's some interesting notes on that too, that we have people that view things very differently, and some of the literature indicated that at certain appearances that it's made, that there have been those who predicted that with its appearance comes some kind of catastrophe for the planet. How would you react to some of those comments?
With the appearance of the Halley's comet?
Yes.
Oh yes, people have been saying that associated with comets is pestilence and disease and wars and so on. And of course there's no cause and effect, so no scientific cause, I will say that right off, but I can understand why people want to blame these poor little comets in the sky just because they have wars and diseases and so on, because there have been many bright comets in the past, but of course there's no connection.
Kurt Nelson.
You mentioned that a comet could possibly collide with the Earth, but it'd be very remote. Is there a chance that we could probably view another comet and maybe get some more data from it? What's the probability of maybe seeing another one within the next 20 years?
This bright, you mean?
Yeah, this bright or this overwhelming. Is this something that we have to do now because we won't get a chance later?
The opportunity here is that we can plan in advance our observations of Halley's comet because we know it's coming. To use large telescopes to observe a comet, to observe anything, one has to apply for time a year in advance, sometimes 6 months in advance, and take time to make an orderly program and orderly observations. So this is going to be the scientific benefit of this time around. But occasionally comets appear out of nowhere, and secretly I think we're all hoping that even a brighter comet will appear in the next year or two, and we'll be all geared up to make the observations that we need to make of this comet. But in the past, when a bright comet appears, astronomers usually are unprepared to make the appropriate observations and get their instruments together. So we're hoping there'll be yet another comet. And in fact, this happened in 1910. People were waiting for Halley's comet, and another bright comet appeared that year. So we hope we're that lucky.
Mary Lou Reed.
Well, do astronomers think differently than other people, Susan? What is the effect of looking at the stars and thinking in terms of distances and time that are really very outside the normal day-to-day world?
Well, that's an interesting question. I don't think we're too different from other people, but certainly we have a very different perspective because we, on a day-to-day basis, are thinking about the universe 5 billion years ago, 10 billion years ago, distances that boggle your mind. These times and these distances never cease to boggle my mind, too. It's a humbling experience to be an astronomer.
A little bit like geologists, where you really do have a different view of time, do you think?
I think you're right. We have a very different perspective when we talk about history in particular.
And are there sometimes a lot of sort of funny things that go along, too, with viewing the unknown? I mean, the stars certainly aren't totally humorless, right?
You're absolutely right. There are a lot of funny things that do happen on occasions when we're observing comets or other objects at the telescope, and can't think of a particular anecdote at this moment.
Well, I think black holes are actually something that I continue to feel are very humorous because I don't understand it. I mean, there's a certain amount of relief in laughing when you don't understand.
Laugh at a black hole, yes.
With that, I have to bring our program to conclusion. And Dr. Wyckoff, on behalf of our staff, you've been so kind with your time, and you've been so informative, and we appreciate very much your coming by. And I know that our viewing audience, as well as the panel, has enjoyed very much your very informative report.
Thank you very much. I hope everyone enjoys the comet.
Ladies and gentlemen, our guest has been Dr. Susan Wyckoff, who is a member of the faculty at Arizona State University. She holds her degree, her doctorate degree in astrophysics, and we've enjoyed this discussion about Halley's Comet. I'd like to take this opportunity to invite you to write to us at North Idaho College in Coeur d'Alene, Idaho, 83814, and we'll respond to your comments. But please be with us again next week at this time when we'll discuss a very important subject. Please have a good week. I am Tony Stewart.
The North Idaho College Public Forum can be seen at this same time each week over this station. This production was videotaped earlier by a North Idaho College student crew for viewing at this more appropriate time.